When we're dealing with our Class A, B, and C IPv4 addresses, we really have two different ranges, categories that they fall into. Public addressing range and private addressing range. So let me tell you a little story here about why we have public and private address ranges. We're going to go back to the public ones right now. See, at one point in time, everything was public. All Class A addresses, B addresses, and C addresses were public addresses. So you wanted internet connectivity, you got a public IP address. It was as simple as that. But let's remind ourselves how many total possible public addresses that limited us to. How long is an IPv4 address? 32 bits. What's 2 to the power of 32? Well, let's just round it out to about 4 point something billion, right? 4 point something billion. You might say, wow, that's a lot of addresses. Oh, yeah, it is. But let's not forget Class D is in there as well. Class E is in there, so we can't use those. Every network is going to have a network ID and a directed broadcast address. Can't use those. So we have less and less addresses that can be utilized. So now let's say we are down, when it's all said and done, in the 3 billion range. And you're like, wow, that's still a lot of addresses. Yeah, it is. But all of a sudden, the internet exploded. Everybody realized, you mean we could put so much stuff on the internet and have free access to that? We could share absolutely everything in this world at the touch of a button. Yeah, we could. So now everybody needs a public IP address. And a lot of people need multiple public IP addresses. And so eventually we ran out of public IP addresses. Just like that. And when did that happen? Back in the 90s. That's right. Back in the 90s. And when I say 90s, some of you might be going, back in the 90s. 1990s. That's right. 1990s. That's when that happened. Years ago. So the overseers of public IP addressing, IANA, and various interest groups got together and they said, well, we got a problem here, right? We are going to run out of public addresses. And what do we do about it? So they decided, well, what if we pluck out of the public ranges some addressing? And we move those to private addressing. Okay, so we can still use public addressing for internet connectivity, but we'll use private addressing for inside homes, for inside corporations, for essentially all those devices that are within some organization. But anything that is connected right to the internet, we'll give them public addresses. Okay, that's going to work. So we still have the public addressing, and the public addressing is basically designed for those interfaces and devices that are directly connected to the internet. And then everything inside your organization or inside your home or inside your branch office, whatever it happens to be, gets private addressing. So what that means is that Cisco and Microsoft and you and any other corporation in this world can all use these addressing ranges internally in their organization without causing conflict. Because remember, IP addressing has to be unique. That's why we ran out of public IP addresses. Because as we're handing them out, if you're using it, so-and-so can't use it. It's as simple as that. But with every single device and every single organization using public addressing and wasting public addressing because of the size of Class A networks and B networks and C networks, right? A and B were the most wasteful. So now we can take back all the waste, get it all back, and tell those organizations that wasted a whole bunch of Class A addresses, go ahead and use private addresses. Go ahead and use the private addresses instead. So they use the private addresses. So now we have preserved IPv4. And this is, remember, back in the 1990s. So we've preserved IPv4, and now it can last a lot longer. It can last a lot longer. But the problem with this is that these private addresses are not routable on the internet. They're only routable internally in your organization. So if you want to go on the internet, these won't work. So they had to introduce another technology called Network Address Translation, NAT, which says, all right, if you have a private IP address and you want to go on the internet, the private address has to be converted into a public address. So Network Address Translation would do that for us. And then when the traffic comes back, that public address gets translated back into a private address, and then the information successfully comes back to your device. So along with private addresses, Network Address Translation was also introduced. But what I want you to memorize is these private address ranges because they're extremely important because you're going to be working with them on a day-to-day basis in your organization. And these are the address ranges that you're going to play around with. You are going to subnet, you're going to deploy, you're going to manage, monitor, maintain. It's these ranges here. You're typically not going to be doing a whole lot with the public address ranges because your service provider will give you the public address and goes on various external interfaces on routers that you have connecting you to the internet. And that's it. You're not going to touch them again. And you're probably only going to get one, maybe two, maybe three, maybe four. But every extra public address you want, it's going to cost you money. So private addressing inside your organization, public on the internet, and then you do network address translation. So Class A is from 10.0.0 to 10.255.255.255. B is from 172.16.00 to 172.31.255.255. C, 172.168.00 to 172.168.255.255.